This is Professor Pelton. This is part 2 of chapter 5, section 2. Then we're going to do quadratic formula, which is the third method of solving quadratic equations. So the first method we went through was isolation, where it was just singular power of x. So you could just do the properties of equality backwards in the order of operations. Then we did factoring, but factoring required that the answer was one of the whole number factors in the factor tree you did out. The quadratic formula allows you to solve ones that have the imaginary and irrational solutions. Thus, you will not find the whole number factors in your list, and this will still work. For example, we take this problem here. If we try to do it the factoring method, I get 1x squared plus 3x minus 5 is equal to 0. So the isolation method will not work because I have multiple powers of x. So if I try to do the factoring method, I get negative 5, right? Although I get a little extra line in there for some reason. I don't know why that is, right? Because if I look at this, 1 times negative 5, which is 1 times 5, or 1 times 5. Neither one of those gives me a 3, right? So this is not going to factor, which means the answer is going to be irrational, right? So I can set up my quadratic formula like so. So x equals negative b plus or minus the square root of b squared minus 4ac, right? All over 2a. So remember, whenever you substitute in mathematics at any level, from kindergarten to college, you must use parentheses to maintain the proper order of operations. So number one, make sure it equal to 0, whether the 0 is on the left or the right, doesn't matter, and then use the parentheses to replace the variables. Okay, so we go to the next one here. We'll finish these off. 25x squared. So if I minus 12, I get what? Minus 20. And then plus 4 is equal to 0. Okay, that looks good. So now we got the 0 on the right in both times, which is fine. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, last one. We'll leave the negative x on this side. So it's negative 1x squared plus 4x minus 13 is equal to 0. Okay. And again, you can put everything on the left or everything on the right-hand side of the equation. So the 0 can go on the left or the right. It's really up to you. Same as factoring. The same works here. Okay. Although you really want a positive x squared in the factoring method to make that a little bit easier. All right. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so in each one of these cases, they're in standard form, which means they're in descending order. So A is 1, B is 3, and C is negative 5. A is 25, B is negative 20, and C is 4. A is negative 1, B is 4. Come on, don't die. And C is negative 13. Okay, so I think we're good here. All right, so I'll plug in the formula. So we're going to plug in the B. So we get a 3, A is a 1, and C is negative 5. Next one, B is negative 20. Let's clean this up a little bit. Okay, A is 25, and C is 4. And in the last case, B is 4, A is negative 1, and C is negative 13. Okay, so we can simplify. So order of operations. So you have to simplify the radical first because the radical is a grouping symbol. So we have 9 plus 20 over 2. Made that line a little bit too long there. That should be fine. So x, whoops, it's still on eraser mode. So x equals -3 plus or minus root 29 all over 2. So 29 is a prime number, so we can't break that down anymore. So just break it into two numbers now. So -3 over 2 plus or minus root 29 over 2. Okay, so that gives me a plus answer and a minus answer, which is two irrational answers, which makes sense because when we tried to do this factoring, we didn't get any whole number factors that work, which means the answer must be imaginary or irrational. Let's try the next one. So x is equal to 20 plus or minus the square root of, what is that, 400, because we're squaring a negative, and that'll be another minus 400 over 50. So x is equal to 20 plus or minus 0 over 50. So essentially x equals 2/5, as the 20 over 50 simplifies and the 0 is really irrelevant. Okay, so we actually get a rational answer there, which means I could have actually factored this, because if you think about it, 25 times 4 gives you 100. There are factors of 100 that will give you 20, right? So that one you could have actually factored or done the quadratic formula. Okay, and the last one, x is equal to -4 plus or minus the square root of 16. So that's three negatives. So the outcome is a negative, right? So 4, 1, and 13 give me 52 all over -2. So x is equal to -4 plus or minus the square root of, so 16 minus 52 would be what, -36 over -2. So that gives me -4 plus or minus 6i over -2. So x is equal to -4 over -2 plus or minus 6i over -2, which is not the final answer. The final answer is actually x is equal to, so 4 divided by 2 is 2, plus or minus. 6 divided by 2 is 3, so 3i. You're like, oh, wait a minute, there's a negative there. What about that negative, right? Well, if you think about it, it's a plus or minus, right? So if you think about it, plus or minus divided by a negative. Well, a negative, positive divided by a negative is a negative, and a negative divided by a negative is a positive. So the plus minus just becomes a minus plus, which is essentially the same thing. So whenever that case happens, just get rid of the negative on the bottom or the plus minus term, because it doesn't really do anything. Okay, pause the video and try the student problems for yourself. And again, you should get one of each of the types here. I get two irrational solutions in the first one. I got a rational solution in the next one, which means the outcome could have actually been factored. And the last one, I get an imaginary answer. So only the middle one could have actually been factored, but all of them could be done with quadratic formula. Okay, so let's go through and do each of the steps all at once. So you can put everything on the left side or the right side. I'm going to elect to do the right side this time. So 9x squared plus 30x plus 25, right? It doesn't matter in quadratic formula which side it goes on, but it is easier to have a positive x squared term when factoring. And then let's see if I do the same thing here. We'll put everything on the right. So 0 equals, so 7x squared. So if I minus 5, that's minus 2x plus 4. And if I minus the x, I get 0 equals -2x squared minus 9x plus 3. So on the example problems, I put the 0 on the right. On the student problems, I put the 0 on the left. But I'm trying to dictate it doesn't really matter which way you do it. All right, so the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. My line's a little wonky there, but that's okay. We'll fix that in the next step. So -b plus or minus the square root of b squared minus 4ac all over 2a. I don't know why my lines are going uphill today. I don't know why that is. So -b plus or minus the square root of, whoops, b squared minus 4ac all over 2a. So remember, whenever you do substitution at any level of math, you need to have the parentheses for the substituted value to maintain the order of operations. Okay, let's put the numbers in now. So B is 30, A is 9, and C is 25. Okay, B is -2, A is 7, and C is 4. B is -9, A is -2, and C is 3. Okay, so if we simplify, x equals -30 plus or minus the square root of 900 minus 900 over 18. Remember, the radical is the first thing you should be simplifying because the radical is a grouping symbol, so that needs to be done first. So -30 plus or minus 0, which is irrelevant in this case. So let's see, 30 and 18, common factor of 6, so that's 5 on top and 3 on the bottom. So that means this one could have also been factored. So 9 times 25, yeah, that could have been factored because I have a rational answer. Therefore, if I did the factor tree, it would have worked out also. Okay, so this one here, x is equal to 2 plus or minus the square root of 4. So double negative, one negative, so it's going to be a negative outcome. So that's 16 times 7 is 112. So over 14. Okay, so x is equal to 2 plus or minus the square root of, so that'd be what, -108? So that's 2 plus or minus the square root of, all right, so I got to break down 108. So that's -1, okay? So 4 times 27 is 108, right? So 4 is 2 and 2, and then 27 is 3, 3, and 3. Okay, 14, not 4. Here we go. Okay, so x is equal to 2 over 14 plus or minus. So we have a 2, a 3. There's a root 3 left over, right? Because you have a pair of 2's here, a pair of 3's. And then we have an I for the -1, of course. So what I really have here is 2 plus 6 root 3i over 14, right? So if I simplify, x is equal to 2 over 14 plus or minus 6 root 3 over 14 and put an I out front. But those fractions can be simplified. Because remember, again, each of these problems do the radical first. The radical is a grouping symbol. So in simplifying, it's the first thing in the order of operations. So x equals 1/7 for the 14th, right? And then 6 and 14 is a common factor of 2. So plus or minus, oh, plus or minus, I lost it there. So 2 is what, 3/7? 3 root 3, 7, and then the I out there, right? Perfect. Okay, so since that one's imaginary, that means that could not have been factored. There are no, so 7 times 2 is 28. There's no factors of 28 that'll give you 2. Okay, so we get a rational answer and irrational answer. So the last one should be imaginary if I did this correctly, because I want to get one of each of the 3 different types. So 9 plus or minus the square root of 81. So that's a double negative, so that's going to be a positive, right? So 8 times 3 is 24. And then -4. Okay, so x is equal to 9 plus or minus the square root of. So let's see, 81 and 24 is 105. So x is equal to 9 plus or minus. So 105 breaks into 5, 3, and 7, which means nothing comes out. It just stays the way it is. So you get x is equal to 9 over -4 plus or minus the square root of 105 over -4. Oops, let me make a better 5 than that. Okay, so remember, so x is equal to, so the 9/4 just stays the way it is. And then plus or minus, in negative, so plus minus divided by negative is negative plus, so it doesn't really change. So it's plus or minus root 105 over 4. Okay. All right, so we had one rational answer, or we could have gotten two rational answers also if it's factorable. We got two irrational answers in the last one. I'm sorry, two imaginary answers for question B, and two irrational answers for the last one, because 2 times 3 is going to give you 6, which is not going to give you the negative 9 in the middle. It's not going to work. Okay, so we've seen the different outcomes for the quadratic formula. Quadratic formula always works, but the other methods fail if it's not a nice rational answer. Because if you get your irrationals and imaginaries, you have to use quadratic formula. So what you see is there's basically three outcomes. Okay, you could get a rational answer, which means it's factorable, and there's just going to be one or two answers on the graph, right? So if it equals 0, you're just going to get one answer, right? That's it. If it's greater than 0, you can get two answers. Okay. And which means you could have factored it. Okay. If it's a perfect square. If it's not a perfect square, you cannot factor. Okay, which means you're still going to get two answers, but it's going to be like 3 plus or minus root 2 or something like that. Okay, again, that's still greater than 0. If it's less than 0 for the discriminant, right? Because again, when you do the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac. The part under the square root is called a discriminant, right? If that's less than 0, which means negative, it's a square root of a negative, which means you're going to get I answers, right? Which means you're going to get this graph over here, which means it doesn't touch the x-axis. You're not going to get any roots, okay? So generally going over the three methods of solving a quadratic. When should I use the isolation method? If you just have a singular power of x, you can use isolation. So if I have 3x squared plus 4x squared equals 7, I only have x squared, I can use isolation. If I have x minus 3 equals 5, very simple algebra 1 problem, there's only x to the first power. If I have 2x is equal to 8, yep, that's fine. If I have 5x minus 3 equals 2x, that's fine because, again, that only has a singular power of x to the first power. If I have a mixed bag, like 3x squared minus 10x plus 7, I have both x to the first power and second power. I have to use a different method, either factoring or the quadratic formula. Well, this is 3 times 7, which is 21, right? Which is 1 times 21, 3 times 7, or negative 1 times negative 21, or negative 3 times negative 7, right? Well, this will give me the negative 10, which means it is factorable, right? As you can do 3x, right? Make a better arrow than that, I think. Go from the top, maybe. 3x divided by 3. So negative 3 and negative 7 are the factors that work. So it is factorable. You can finish the problem and get the answers if you want. They'll be rational answers. Okay. If I had something very similar, 3x squared minus 2x plus 7. So very similar problem, but I only changed the middle, right? Okay. None of those give me negative 2, which means I must use the quadratic equation, right? X equals negative b plus or minus, quadratic formula, sorry, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'll either get two irrational or two imaginary solutions. That's the only possible outcome. Okay, that gives you the outline of the solving methods you should use.